Hello there, Mr. Sutton here, bringing you the IM3 1.2 extra practice solutions on the substitution method. To solve this system with the substitution method, we need a variable to be completely isolated in one of the equations. Now, if we look over here, the first equation, that's already done for us. Y is already by itself, so wherever I see a y, I can actually just replace it with this 8x that it equals. So I'm going to substitute 8x for the y over in this second equation here. So I'm going to rewrite this as x minus 8x equals negative 14. And then I can simplify the left side of the equation. So that's going to be negative 7x equals negative 14. Dividing by negative 7, we have x equals positive 2. And now to find the value of y, I can substitute 2 for x over in this equation up here. I could actually do it in this other equation, but this one's going to be a little bit faster. So we have y equals 8 times 2, which means y is going to be 16. So our final answer then is the point 2, 16. To solve this system of equations using substitution, I need a variable to be completely isolated in one of my equations. It looks like the y over on the left equation here is already all by itself. So wherever I see y, I can replace that with 7x minus 23. So I'm going to use this y over here in the second equation and replace that with 7x minus 23. That'll be my first step to make that substitution. So I've got 4x plus 3 parentheses 7x minus 23. All of that equals 6. And now since I only have x's in that equation, I can go ahead and solve. So this will be, let's see here, 4x plus 21x minus 69 if I distribute there. So that's 25x if I combine those x's on the left. And let me just add the 69 over to the right. So that's 75 over on that other side. So then dividing by 25, I have x equals 3. Now to find y, I just plug 3 for x in one of these original equations. I'm going to use this first equation since we already have y by itself over there. So plugging 3 in for this x right here, we've got 7 times 3 minus 23, so 21 minus 23, which gives me a y value of negative 2. So then my final answer is the point 3, negative 2. To solve this system with substitution, I first look for a variable that's all by itself in one of the equations, and I luck out here. This x is already completely isolated. So now I can replace x with negative 4y minus 1 whenever I need to. And I'm thinking I need to over in this first equation because I have x's and y's, and I only want one type of variable. Otherwise, I can't solve. So I'm going to do 5 times all this stuff here that x equals. So 5 parentheses negative 4y minus 1. All of that plus the 7y that's still left over there. And distributing that 5, we've got negative 20y minus 5 plus 7y equals 21. Combining like terms, that's negative 13y on the left side. We still have a negative 5 over there as well. Adding that to the other side, that's going to be 26 on the right side. So we have y equals, let's see here, negative 2. Now to find x, I just plug negative 2 in for y wherever I need to. I'm thinking this equation that already has x isolated is a good spot. So I'll plug negative 2 in right here. So this will be negative 4 times negative 2 minus 1. That's going to be 8 minus 1, which gives me an x value of 7. So putting it all together, we have the point 7, negative 2 for my final solution here. On this one, they want me to figure out the solution to this system using substitution. So for substitution, I need to get a variable all by itself in one of the equations. That's not already done for me, so I'm going to have to do it on my own. I'm thinking the y in the second equation here is going to be the easiest one to isolate because it doesn't have a coefficient other than negative 1. So let's see, add or subtract rather 8x from both sides. So we have negative y equals negative 8x plus 9 or 9 minus 8x. So that'll be my first step. And then to truly isolate y, I can't have a negative next to it. So I'm going to have to multiply everything in that equation by negative 1. So I can write y equals negative 9 plus 8x. And now let me replace y with negative 9 plus 8x over in this first equation right here. So I can write 3x plus 6 parentheses this stuff, negative 9 plus 8x. All of that equals negative 3. Distributing that 6, I've got a negative 54 plus 48x. Combining like terms, we have 3x and 48x. That's going to be 51x minus 54 equals negative 3. And then adding 54 to both sides, that's going to be positive 51 on the right side. And that works out pretty well. So x is just going to be 1. Now to find y, I plug 1 in for x over, well, any of these equations is fine, but how about this one where y is already by itself? So we have y equals negative 9 plus 8 times 1. So basically negative 9 plus 8, which comes out to negative 1. And that gives me the final answer of 1 comma negative 1. For this one, I want to solve using the substitution method. In order to use this, I need a variable to be completely isolated in one of my equations. Easiest variable to do that with is going to be the y in the first equation. So to get that, I just have to subtract 3x from both sides. So I can write y equals negative 1 minus 3x or negative 3x minus 1, either way you want to write it. And now I can replace y with negative 1 minus 3x whenever I need to. So over here in this second equation, I'm actually going to do that. I'm going to take negative 1 minus 3x and plug it in for this y right here. So I can write 5x minus 3, now parentheses, negative 1 minus 3x. And we have all of that still equaling negative 4. Now this looks kind of messy. The good news, though, is that we only have x's in this equation, so we can now go ahead and use normal algebra to solve for x. So let me distribute this negative 3 to this parentheses. That gives me positive 3 plus 9x. Then 9x and 5x gives us 14x. And finally, subtract that 3 to get the 14x alone. So that's negative 7 on the right side. Dividing both sides by 14, be careful here. This is going to be negative 7 over 14, which is negative 1 over 2. I still need to plug this back in to figure out the y value. So plugging negative 1/2 in for the x up here seems like a good place to do it. That's negative 1 minus 3 times negative 1/2. And to add these together, well, let's see here. This would be positive 3/2 minus 1. Minus 1 is kind of like negative 2 over 2 if we rewrite that with a denominator of 2. So this all then is going to add up to positive 1 over 2. So final answer, negative 1/2 comma 1/2. That's our point.